Hello everyone, and today we will continue our basic studies of differential equations. These introductory lessons are about differential equations. And today we'll talk about first order linear equations and specifically homogeneous equations. And as I said in the last video, linear equations are equations of this kind. We have a function of t, we have the nth derivative of x, and so on until a2 of t, x double prime plus a1 of t, x prime plus a0 of t times x equals, and will equals 0 because I'm talking about homogeneous equation. And if you are interested in first order, we just have these functions until the first order of derivative of our function x. Remember that x is a function of t, and we will find solutions of equations like this one. A1 of t times the first derivative of x plus a0 of t times the function x equals to 0. Okay, so first of all, we need to guarantee or satisfy that in the interval that we are trying to find solutions, we have a1 of t different of 0. Let's say t belongs to an interval ab, and inside that interval we are find our solution. Another thing important to say for this equation is that it is a special case of a separable equation. Separable equation. And by separable, I mean that we can put the two variables, the dependent variable x and independent variable t, on both sides of the equal sign. I must show you in a second, but I'm gonna make a video about separable equations as well, the general cases of separable equations. But the first order homogeneous equation is a special case of a separable equation. Now, to solve this equation, we must divide, for simplicity, both sides by a1 of t. So we must have x prime plus, let's say, capital A of t times x equals 0. And I'm gonna put inside the parentheses that a naught of t divided by a1 of t, we are redefining it as another function, capital A of t. And it is a separable equation. To solve separable equations, we must exchange x prime by dx dt, and you will see why we do it. We write dx dt Let's put this on the other side, and we have minus capital A of t times x, and we know x is a function of t. And by separable, we call it a separable equation, and don't forget, it's a special case of separable equations because we can put dx on the left side, or we can put the variable x on the left side. In the right side, we only have the variable t, the independent variable t. Just pass the t multiplying. So this is almost our solution, because now we just have to integrate both sides so we can have our solution. Integrating both sides, we know that integral of dx divided by x is natural logarithm of our function, our solution x, and we don't know what function that is, so we just put in that way minus a of t integral dt. And we also know that by those integrations we have a constant. I'm gonna call it capital C, and exponentiating both sides we will have x of t being equal to exponential of minus integral of capital A of t dt plus c, but we know that exponential of, let's say, x plus y is equal to exponential of x times exponential of y, and exponential of c I'm going to define as another constant, capital B. So we will have this x of t equals capital B times this exponential. And I want you to note that this is a family of solutions. It is indeed a one parameter family of solutions. Because B is an arbitrary constant. Arbitrary constant. But for each initial value problem, we're gonna study this after, but IPP is what we called initial value problem. If we say the initial conditions of this equation, like x in the time 0 being the initial position, for example, then we can find our constant b. So that's basically that's how we solve this equation. I can put some examples here. Example 1, let's make x prime plus x equals to 0, and let's say that our initial condition is equal to 1. So we can solve it, this initial value problem. It's very easy, right? dx dt equals minus x, and then dx divided by x equals minus dt, and integrating both sides we have natural logarithm equals minus t plus constant, and then exponentiating both sides, we have x of t equals capital B times exponential of minus t. But we know that by our initial value, uh, it's equal to 1, and then 1 is equal to b times exponential of 0. But exponential of 0 is equal to 1, so then that's the value of b. And then our solution will be exponential of minus t. That was a very easy problem because, as we know, we have the derivative being equal minus the own function. In other words, I'm looking for a function that the derivative is the own function with a minus sign, and it's obviously this is the solution. uh, I guess there's not hard problems of first order homogeneous as we see. Other examples I could put here would be so much easy as well, and we must finish our video. And the only difficulty would be find this integral of capital A of t. Sometimes this function A of t could be a function that cannot be integrated to find an elementary function, but we can use numerical methods to integrate and find our solution. So that's it. Thank you for watching and see you next time.